Hey everybody, wanted to go over 20.23 and it's balancing half reactions, okay? So this is kind of the first major step when you're balancing half reactions in catalyzed solutions. Remember, there's either acid catalyzed or base catalyzed, and so it's important for us to go over how to balance these guys, and let's get started. Okay, so this is already the half reaction. Okay, so for A here, okay, we have SN2 plus going to SN4 plus. SN2 plus reacts to form SN4 plus. And I'm a bad chemist, I leave my states off of these things, but notice here I'm leaving space here and I'm leaving space here. Okay, because we're going to end up having to add electrons to one side or another, and I just don't know which side we're going to have to add it to. Okay, so I always leave lots of space when doing this, and I don't know why that just popped up. Okay, but let's close that stuff. There we go. Okay, so first thing we should do is balance by atom. Tin and tin, there's one of each. Perfect. And then, after we balance the atoms, which they already are, we should balance the charge. And so we have 2 plus, and we have to get that equal to 4 plus. The only way we can do that is by adding electrons to the product side here. We have a 4 plus, and then 2 negative charges. Bring this side, and I'll do this in green. Okay, this side, now the total charge is 2 plus. Okay, the total charge on this side is 2 plus. 2 plus equals 2 plus. Life is good. Okay. Now, B. This is where it gets to be interesting. Okay, because we have TiO2 reacting to form Ti2 plus, and it's an acidic solution. But you'll notice that this compound here, this compound which my uncle really likes. Okay, anyways, there's oxygen on this side, but not on this side. Again, don't know what's going on here. Get rid of it. Okay. Okay. So, again, don't know why is there oxygen on the reactant side and not on the product side? Well, we can balance that because we have acid that we can balance, so that there's a stepwise progression to balancing half reactions. The first thing that we do is we balance the non-oxygen and all the non-oxygen and hydrogen atoms. In this case, titanium, Ti. Okay, one on each side, completely balanced. The next thing we do is we balance oxygen using water. So this is going to be plus 2 H2O, because each oxygen, there's 2 oxygens here, so we need 2 oxygens on this side. Okay. Now, some people have a question about where the water comes from. Well, this is a solution here, okay, and so there's so much water floating around that you can use it anytime, any way that you really want, okay, especially in these sorts of reactions. Okay, so now the third part of this is going to be balancing the hydrogen atoms using H plus. Okay, plus 4 H plus, and we do that because there's 4 there. Okay. So 2 times 2 is 4 hydrogens. So now everything is balanced using atoms. The atoms are all balanced. Sometimes we call it mass balanced. Okay, but it's not charge balanced. So here we have 4 pluses on this side. I'll do that in green again. Okay, 4 pluses. Here we only have 2 pluses. So in order to get this balanced, we're going to have to add 2 electrons to this side of the reaction. Okay, and so that's so now that's a balanced half reaction. Okay, and This is a gaining of electrons. So Leoger, even though it doesn't say it, we could call this a gaining of electrons, which is a reduction. Okay. Now the next one, ClO 3 minus. Okay, reacts to form Cl minus. So this is very similar to the one above it. Okay, we're balancing it in acidic solution. So we balance non-oxygen and hydrogen atoms first. Okay, so when we do that, we have chlorine balanced, good. Okay, and so now we would balance this. The oxygen's next with H2O, but there's 3 of them, so we need 3 H2O here. And now we balance the hydrogens with H+. It's in acidic solution, so we're going to use H+. So there's 6 plus 6 H+. Okay, so that's cool. Now we have to charge balance. So again, I'll try this in green. This side, I'll do it on the bottom this time. Okay, this side there's a minus here and 6 pluses, so that's a 5 plus total. And then this side is a 1 minus. Well, how do we get 5 plus and 1 minus to equal each other? Well, we're going to put plus 6 electrons on this side of the reaction. Okay, and so again, if it's adding, that's got to be a reduction reaction. Okay, so now part D. Okay, we have N2 reacts to form NH4 plus. Okay, so we want to balance this. Okay, nitrogen gas going to ammonium ion. Okay, we're going to first balance using excuse me. We're going to first put a 2 out in front of there because this is the first one in this series where we have a we have to actually balance the non-hydrogen and oxygens. Okay. Now the next thing is to balance the oxygens. Now there's no oxygens to balance in this case using water. So if there's no oxygens, now we go to the next step. The next step to balance would be balance hydrogens using H+. So we're going to do 8H+. And now we're going to charge balance. Okay, so this is 8 plus here and 2 plus here. The only way to get that equal is by putting 6 electrons on the reactant side. Okay, so there's that. Okay, now E is now balancing, going in basic solution. So it's going to be OH minus reacts to form O2. And just double check. That's what that says. Okay. And so now we balance this the same way we do with hydrogen, balancing in basics or in acidic solution, except we're going to add a little step at the end. Okay. So again, balance all the non-hydrogen and oxygen atoms. Already done. So there's no non-hydrogen and oxygens. Balance the hydrogens using water. Okay. Well, this is going to be interesting because we're going to need we need to balance the oxygens using water. Okay. Make sure that I'm being not crazy. So we're going to put plus H2O here. Excuse me. Okay. And so that's 3 H's, and so now we're going to balance using H+. Okay. And so we're going to put 3 H+ on this side. Now, here's the thing. This is in basic solution. And so what we're going to do, and so balancing in an acidic solution is kind of like the shorthand notation for basic. So you balance like it's in acidic solution, and then to make it basic, what we're going to do is, since it's all nice and balanced, we're going to go plus 3OH, because that's going to cancel out the H pluses, and then we're going to go 3OH minus on this side. Okay, so now this turns into 3H2O, and so now I think it begs us to actually take a second and rewrite this reaction and combine things. So we have 3 hydroxides and 1 hydroxide. So that's 4OH minus plus 4 plus an H2O reacts to form O2 plus 3H2O. Now, we can also cancel this out and cancel out another one of those, so that's 2H2O. Now, the only other thing that we have left to do is balance using charge. So now we're going to add electrons. So we have a 4 minus on this side, and it's neutral here, so we're going to put plus 4 electrons. So that's balancing that reaction in basic solution. Okay, so now let's try F. That's sulfite going to sulfate. Okay, so again, don't know why that happened. Oh, I changed my view. Okay, so we have the sulfite, sorry about that. Okay, so we have the sulfite ion, SO3. I guess I didn't fix my pen sensitivity. Okay, so it's SO3 2 minus, reacting to form SO4 2 minus. Okay, just double check that that's right. Okay, yes. So now we just balance this. It's in basic solution, so we balance this like we do any other reaction. Okay, balance the non-oxygen and hydrogen atoms first. So it's 1 and 1 sulfur, so that's balanced. Now we balance oxygen using water, so we need plus 1 H2O on this side. Excuse me. And now we're going to balance hydrogen using the hydrogen ion. Now, again, it's basic solution, so we use the hydrogen ion as a placeholder. Once we have that, we can now add 2 hydroxides on this side, and what's on one side we have to put on the other side, so plus 2 hydroxides here, and so this 2H plus plus 2OH minus gives us 2, here I'll write it this way, maybe it's a little easier to see HOH, water. Okay, and so now we've gotten rid of the acid, and now we've made this base catalyzed, or we've represented it base catalyzed. This isn't representative of the chemistry that's going on, but it's definitely the way to balance this guy. So I think we should spend a second and rewrite this. Okay, so we have S, if I can here. Okay, so we have SO3 2 minus plus, and now I'm going to combine them. Look, I have 2H2O and 1H2O, so it's going to be plus 2OH minus, reacts to form SO4 2 minus plus H2O. The only thing we have left to do is balance this based on charge. So we have 3 minus here, 2 minus here, so we have to put 1 electron on this side. Okay, so that's how you balance that guy. Now, that's losing electrons. The electrons are being produced or given off. They're on the product side. So if that's the case, then you have a oxidation reaction. Okay, and so let's do nitrogen gas turning into ammonia. Okay, so we have nitrogen gas, N2, reacts to form ammonia, NH3. Okay, so again, balance the non-hydrogen and oxygen. So the nitrogens need to be balanced here. Now, again, we don't need to balance the oxygens because there's none there. So that means that we just have to go and balance the hydrogens using H+. So there's 6 on the product side, so we're going to go plus 6H+. And we know that it's basic, so we're just using the H+ as a placeholder. And so now if we have 6H+ here, we're going to put plus 6OH minus here, and then 6OH minus here. This combines to form 6HOH. Okay. And now we can, I think, rewrite that guy just to make it look a little nicer. We get N2 plus 6 waters, H2O, reacts to form 2NH3 plus 6OH minus. Okay. Okay. Good. Okay. So the last thing we have to do is balance charge. So we have 6 minus on this side, nothing on this side, so we have to go 6 electrons over here. Okay. 6. I guess this is what happens when you rely on technology, is you have silly pen issues sometimes. 6 electrons. Okay. So there it is. That goes through all of those reactions,